we looked last time, okay, at some definition for the entities, and we look at we can specify an AR model, okay, and we started by looking at the example of the company database, where we said this is an example or sample of data model, where you can model your database, your design. You can show your design in a graphical way, and all those, as I mentioned, all those symbols they do have some meaning. Okay, we're going to see inshallah in special chapter which is really dedicated to the ER. So you will learn how you can draw this type of diagram, whatever the requirement. Based on the requirement you have, okay, you will design an ER diagram model. And we looked at what is meant by an entities, what is relationships and attribute. Okay, we said that an entity is something that is from the real world with independent existence. Attributes are considered as some properties for some specific entity, and the attribute we define a composite against we do have simple, we do have single value against multi-values, we do have the stored and the derived, we do have a null value, and we do have a complex attribute. Okay, and we looked at some examples. Now, with regard to the entity itself, okay, we said that we do have an entity. Entity, by definition, it is, or a set of entities have, here we talk about the set of that have the same attribute. Okay, for the database, usually when you do have a database, okay, when you talk about an entity type, usually database contains some group of entities that are similar, like what we did last time. We looked at the employee. Okay, if you remember, we looked at employee. We said that E1 is an employee that is an element of the entity employee. Okay, because this is like a set, majmu'a, and what you are going to put inside that set, all the employees, all the entities that have similar characteristic. Okay, if I do have entity student, what I will find inside that entity that is called entity student, I will find all the students. Okay, because they share the same characteristic. They do have, or they share the same characteristics, and they do have the same attribute. That's why we put them on the same table or entity. We cannot put, for instance, in the employee table or the employee set, we are going to put a department inside it, because the department and an employee doesn't share, or they don't share the same characteristic and attributes. That's why, for instance, you might find in the employee entity, okay, we might find thousands of employees, okay, and those thousands of employees, they share the same information. Okay, you will have the same information for each employee. For each employee, I have this attribute: his name, his birth date, social security number, sex. Naam, yes.
Yeah, my question is, so you know this diagram, like this diagram in front of us. Instead of this diagram, what if this was a flow diagram? You understand flow diagrams?
The flow diagram it's not. It doesn't show the design. Here we talk about the database design.
No, but can we not design the database on a flow diagram? Like it starts with the company, then the departments, then the managers, and then the employees.
Now, how can you show the relationship between the different entities? Whether the relationship is 1-to-1 or 1-to-n. Okay, yeah, the attribute as well. So you have to use UML diagram, for instance, or this AR diagram.
Okay, thank you.
Okay, you're welcome. I said, for instance, you do have 1,000 employees. Okay, and each employee you need to store for each employee these types of attribute: his name, his birth date, and so on. So where you are going to put those all employees that have the same, or they share the same attribute? Okay, of course, they will have their own value for each attribute. When we talk about an employee, for each employee has sex, salary, address, last name, birth date, name, middle name, SSN as attribute. But for each individual employee, they do have their own value for each attribute, like we saw in our diagram, in this example, for this employee, for instance, he shares the same attribute, name, address, age, and home phone, but the value for each attribute is different from one employee to another employee. Okay, so this employee, okay, we put them inside an entity, okay, we call entity type, which is in reality it is like a collection of sets. Okay, you do have a set of employee and you do have all those employee. For instance, E1, an employee E1, these are the values for his, let's say, attribute. This is another employee E2 who has this value for the attribute. Okay, for instance, his name, age, and salary. For instance, name, age, salary, name, age, salary. Okay, so if you can see here what we did, we put in the employee entity name, age, salary. These are the attribute, and these are the values for each one of those entities or employee or element, and you can find as much as you do have in your database. The same thing applies for the company entity. Okay, where I said I do have entity that is called company. What I will put in that entity, I will store the name of the company, the headquarters, and the president. And I do have many companies. Company 1, for instance, this is the name, this is the headquarters, and this is its president, for instance. Company number 2, I do have this information for such company, and so on. So at the end, what we say that, let's say, within an entity type or entity sets, we do have, let's say, we are grouping entities, okay, that are similar. These are entity, okay, entities. That means the element of my set, which is the employee itself. Okay, Shabab? So it is very important to understand the principle of the entity. As we mentioned, for instance, for the employee, refers to both a type of entity of, let's say, for all, or let's say that has a current collection of all the employees entity in the database. Okay, it is common for you to see the data, which reflects the data inside the employee entity, for instance. And now how we are going to represent in our ER diagram an entity, it is represented by this rectangular box. When you see a rectangular box, automatically you will say, this is the way how we can represent an entity. This is an entity employee. This is an entity department. This is an entity project. And you know that inside it, you do have elements that are part of the project and they share the same attribute, name, number, location. When I do have some element inside the department entity, I will find department or element that share the same attribute, name, locations, number, with different, of course, values for name, locations, and the number, and so on. Okay, Shabab?
Yes.
And also to mention for the entity, as we mentioned, for each entity, we do have the attribute. And the attribute name are put in an oval symbol. Okay, when you see an oval representation, means these are the attribute or attributes for such entity. And there will be a straight line that will connect the entity with its attribute. Okay,
Dr.
for each
Ahmed.
attribute, naam.
Dr. Ahmed, are you going to ask us to make this in the exam?
Yes, of course. Yes,
okay.
yes, Shabab, yes.
Okay,
In the exam, you will have like this one. Okay, you do have some information, and you will be requested to draw a diagram, an ER diagram model for that specific requirement.
Doctor,
Okay, Shabab?
But it looks as if this is a business management class.
It is not
Is
a
that what
business
this-
management. It is a representation for the design, for the database design. It is not. It's not related to anything of business. It reflects the design of your database. Because from this diagram, you will move to the implementation inside the computer where you will create all those entities, and you will learn in the coming chapter, inshallah, how you can do the translation from an ER diagram into a computer-based representation or implementation.
Okay, thank you for that.
Okay, Shabab, you're welcome. And also, as I mentioned, you do have attribute. You do have those attributes attached to their corresponding entity with straight line. Okay. For the multi-valued, you will see a double oval representation like this one. I do have a double oval. That means this is a multi-value attribute. Okay, multi-valued attribute. Shabab, this is a simple attribute. And this is the multi-value. That means the department may have many locations, for instance. Okay, we're going to see later, inshallah, about all the representative of each one of those parts within an ER diagram. Now, let's move on to something that is related also to the entities, to some data inside your database. Okay, we do have what is known as a key or uniqueness constraint. Now, this is a very important constraint on the entities of an entity type. Here we talk about entities and entity. Entity means this one. Okay? And entities are the element inside your entity. Okay? Now, for each entity, okay, within the entities, when we do have entities, you do have some constraint. Constraint, that means something particular for that entity type. And what is that particular attribute or the constraint is what is known as a key, or we call it uniqueness constraint. Okay? That means, and usually what we do have within an entity, we do have many attributes. Okay, as we mentioned here, name, age, salary, and other attributes. But how can I make difference between this element E1 and E2? Based on what? The same thing. If I tell you, for instance, I do have student entity, and inside my student set, I do have student Omar, student Ahmed, student Ali, student Muhammad. Now, how can I differentiate and make sure that the information, or let's say the record of Omar, student Omar, is different from the information of Ahmed record or Ali record? And here comes an attribute. Among those attributes that you are going to specify, there will be an attribute which we call a key attribute. That means I might find, and this is what will happen, and this is what you should have in your database, to differentiate between one element of the set employee and another element of the same set. We should have at least one attribute, we call it key attribute, that is unique among all the entities. Like in PSU database, for instance. What is the unique attribute for student, between student? Shabab.
Student ID.
Student ID.
Student ID. Thank you. Student ID. You will never find a student ID, the same student ID for two different students. And that attribute inside the database, which is called student ID, we call that attribute, we call it a key attribute. It is unique. It does have a uniqueness property that will hold for every entity set of the entity type. That means for each element inside the entity student, each element has different key attribute for, or different value for the student ID. And we call that student ID as a key attribute for that entity.
Doctor?
Yes?
Can we have more than one key attribute for one entity?
Yes, we can have more than one. We can have more than, we call it a composite key. You're going to see, inshallah, later.
Composite key.
Yes. It's not necessarily the key should be only one attribute. I might choose to have, for instance, let's say it's like, for instance, when you do have hotel rooms, for instance. You do have many the same brand for the hotel. Okay, I do have let's say ABC brand or chain, hotel chain, and I do have a location for that ABC in Riyadh. I do have the same brand or the same chain, the same hotel in Jeddah, and I want to verify, for instance, whether there is a 3-room to book, for instance. Here, what we need to identify, let's say, our hotel based on the hotel name, for instance, and location. I will say, because I do have in my database many hotels, okay? And there are different types of hotel chains. Okay? I do have ABC hotels chain, I do have XYZ hotels chain, and so on. So how can I, if I pick up the ABC hotel, I do have a location in Riyadh and I do have a location in Jeddah. Now, how can I make difference between those two locations? I will pick up the name of the hotel, ABC, which is an attribute, with the location, and this will make my, let's say, hotel different. Let's say the ABC hotel in Riyadh is different from ABC hotel in Jeddah. So I can precisely say which room I want to book, whether the location based Riyadh or location based Jeddah. So you might find many examples that are related to a composite, a key attribute or key value for some specific entity. Okay?
Doctor, meaning
Yes.
that we can have multiple hotels with the same name and multiple hotels in the same city, but the combination of name and city must be unique, right?
Yes, yes, of course, yes.
Thank you.
You're welcome. Okay, so the idea is about the key attribute. That means if when you pick up, I cannot, for instance, can I say, for instance, Shabab, the student name, well, a student age. The student age attribute, I will choose it as the key attribute for my entities. Can we have that or not, Shabab?
No,
the age. No. I do have age attribute. Okay, if I go to my ER diagram. Okay, I will pick up birth date. I will say birth date is my key attribute for the employee entity. Is that true, Lala? It is not unique. Okay, why we can find 2 employees or 2 students having the same birth date. I might have 2 students having the same address, 2 employees having the same salary, the same sex, but for the social security number for the employee example, or for student ID, that attribute is the key. As we mentioned, we cannot have 2 students or 2 employees having the same attribute or same key. Okay, and by the way, how do we know which attribute in our diagram is the key? By looking at the attribute that has an underline. When you see an attribute with an underline, that means this is the key for this employee. For the department, if you can see, yes, we do have here 2. Okay, this is another example. For the department, I do have the name and the number. Both of them are considered as a combination to form my key for the department entity. Project as well. For the project entity, we choose to have the name and the number. Both of them are underlined. That means the combination of these 2, name and the number. We are not saying only name or number. No, name and number are considered my key for the project entity. Okay,
Doctor, why locations in department has 2 circles?
Now, we said that this is a multi-valued. That means it might have more than 1 location for the department. Like we did for the hotel. We said the hotel, we can have a hotel or a bank that has many branches at different locations. So you need to, that is a multi-valued. I will say Rajhi Bank in Riyadh has Ulayya location, whatever, Salah ad-Din location, and so on. So that means that value might have many, or that attribute might have many values, which is a multi-valued attribute, as we mentioned in our last session. Okay, Shabab? So this is for the key attribute. We said it provides you a uniqueness property. Now the value sets, we call it the domain of values. It is in reality what? Specify the set of acceptable values that you might assign to that attribute for each individual entity. Okay, let's pick up. In reality, what is it when we say a domain of values? Okay, if we go to the same example, we pick up, let's say, salary, for instance, simplest attribute. Can anyone tell us what is the domain of values? When we say domain values, that means what are the acceptable value that can be assigned or given to the salary attribute. Can I find in the database salary value equals to ABC?
No.
No. So what is the acceptable? Now
Should be a positive integer.
Should be an integer, for instance. On its simplest way, not integer, maybe float. I can have a salary 10,500, for instance. That means at least I would say salary is a number. Okay, we don't specify whether an integer or a double or a float. Just let's say consider the salary is a number. That means the domain of the value that we should put for the salary attribute should be within that domain, which reflects the data type. When you specify the data type for each attribute, you are defining the domain. You are saying the only acceptable value for that specific attribute should be from this domain or from the value of set of the value. That means when I say integer, I can positive integer, I should have, let's say, the range of the positive integer, for instance, and so on. So this is what is known as domains of values. Okay, Shabab? And this is another example, what we mentioned for the key attribute of an entity. Okay, we might have, for instance, for some entity type, we might have more than one key attribute. Okay, for instance, this is an example. For instance, a car. I do have a car. I do have a registration, and I do have a vehicle ID. These are the key that might be considered as a key attribute on their own. Okay, it does have two key attributes. Here, not necessarily. This is just showing you that we are specifying registration and vehicle ID are considered as a key attribute. Now, when you go to do implementation, okay, when I go to do an implementation, I will specify, maybe I will take only one of them because it is enough. By having only registration, let's say number plate, can we have two cars with the same number plate, Shabab?
No.
No, we can.
No. Can we have two cars with the same chassis number?
No.
No.
No. That means
No.
not necessarily I have to have this combination. Not necessarily I will say when I do to the implementation, when I will create my car entity in my database, not necessarily I will say registration and vehicle ID are my key attribute. Yes, I will say this is the key attribute, this is key attribute, but when I do implementation, I will choose only one of them. It is enough because choosing one attribute of them, whether registration or a vehicle ID, will be enough for me to differentiate between one attribute and another, between one car entity and another car entity or element. Okay, but because each key is on its own key attribute. Registration, it is on its own. It doesn't need to be with vehicle ID to form my key. Not like what we did, we saw previously. Okay, when we saw previously, here we need to have, for instance, name and number together. We cannot only have a name because I cannot differentiate, let's say, computer department. Suppose that you have, for instance, yes, computer department of PSU, and PSU has many locations. Okay, so we cannot say computer department of PSU. In which location? Riyadh location, or Jeddah location, or Mecca location, a number, which is really here based on the number, for instance. So I need to specify name and number together. But in some example, in some environment, some scenarios, okay, you will define, you will say this can be a key for my entity. This also can be a key of my entity. But when I do implementation, I will choose only one of them. Clear, Shabab?
Doctor.
No.
In the diagram, it looks exactly the same. So how can we differentiate?
This is, as we mentioned, this is your data. Okay, you are the designer. You are designing your database. Okay, this is just an example. For here, for in this example, it is necessarily to have name and number together. To have name and number together for the project. Okay, but sometimes when you do, for instance, you are doing a draft of your diagram, and you are saying you are just specifying each entity on its separate graph or diagram. So just for your information, you are specifying this and this. And this is just an example for you to show you that these are which are known are elected key or the probable key for this car entity.
So it's not necessary for the diagram to differentiate. It's the job of the designer.
Yes, but when you do your ER diagram, let's say the final ER diagram, you need to underline only those attributes that will be considered as a key. Okay, don't confuse anyone. For instance, here when we underline name and number, that means I will choose name and number, and with and, not or. Okay, and this is the example just to explain to you that we might have more than one entity that can be elected, sorry, more than one attribute that might be elected as a key attribute for that entity. Okay, Shabab?
So here at the end, only one of them will be underlined.
Yes, only because these are the candidate key. We call them candidate key. Okay, when you do have candidate, for instance, I do have two persons that have been elected to run, for instance, election. Okay, but at the end, one of them will be president. So I will choose later. We choose only one. But here, just to show you that this is the candidate key. As you might choose both of them, because it is the choice of the designer. Okay, maybe you will choose registration. You will say, no, for my database, I want to be more precise. I will choose registration and vehicle ID to be part of my key attribute for the car entity. That's fine. But another designer will say, no, why to choose only those two? One will be enough. So one will choose registration. Another designer will say, no, in my database, I will choose vehicle ID. And all of them are right. No one is wrong. As long as the attribute you are choosing will differentiate the car entity, the element of the car, one car from another car. Okay, Shabab?
Okay.
Okay. These are, let's say, initial conceptual design. As we mentioned, you will design each one of them separately. Okay, you do have employee on its own, dependent, project, department. Then you will do some refinement. You will choose. Okay. Now we do have relationship. Relationship is the thing that will relate and link one entity to another entity. Okay, here we talk about one attribute of one entity types refers to another entity type. That means from one entity, you will refer to another entity. Okay, when we did here employee entity, we are referring, when you see these types of relationship, we are linking employee and department through this type of relationship. I am linking the employee with the department through this relationship. And relationship will be represented in a losange diagram or symbol. I am linking department with the project. This is the link. Okay, they are not separated. This is our initial diagram or initial diagram without any link. Then you will decide is there any relationship between employee and department? If yes, you have to specify what type of relationship. Is there any relationship between department and project? If yes, you will create that relationship and specify what type of relationship. So the relationship will represent, it's a reference you will do, for instance, from one attribute in one entity will refer to another attribute in another entity. Okay, these are represented as relationship. We are not representing attribute. Okay, this is the schematic or mathematic representation of relationship. We say that relationship type are among n entities type. That means these are the entities. E1, E2, En. These are the entities, and you will define a relationship. We call it R relationship. This is an instance of relationship. That means you will have each individual entity in one, each individual entities in one entity will be related to another entity. Let's have a look. This is an example. This is the employee table or employee entity, and this is the department entity. This is the relationship works for. Okay, this is an instance of a relationship. We say works for R1, R2. This is what we mentioned by the relay association, R1, I2, like we did here in our ER diagram. We did have a relationship between the employee and department through relationship works for. Okay, if you look at, if you open that employees set, or employee entity, and if you open also that department entity or a department set, you will see each individual element inside the employee is related to a department element, some department element inside this set through a relationship that we call works for. And this is how we represented such relationship. We represented such relationship by saying, by having a line between an element of employee and another element of the department through this relationship. I will say E1 is related to D1 via or through the relationship R1, which is works for. That means this employee works for the department 1. This employee E2 works for, R2 is works for the department 2, and so on. This is a representation of a relationship set, which represent relationship types works for between the employee entity and the department entity. Clear, Shabab?
Yes.
Okay.
Yes.
Now the degree of relationship. When we say what is the degree of relationship? The degree of relationship is the number of participating entity types. We might have binary degree or ternary degree. What is meant by participating entity types? Okay, here, how many entities are participating in the works for relationship? This is a relationship, Shabab. Don't confuse it with entity. This is a works for relationship. How many entities are involved in this diagram? Two. We do have employee entity and the department. We say this, the degree of this works for is 2. It is a binary. That's why binary معناه 2. That means we do have 2 entities are related through this relationship, which is works for. We might have more than 2 entities, which is known as a ternary. Can you see this type? This is another example. I do have supplier entity. I do have a project entity. I do have part entity. And this is supply. This is my relationship, the biggest one. It is related between how many entities, Shabab?
3 entities.
3. Supplier entity, project entity, part entity. That means 3, ternary. We say the supplier S1 supplies, this R1, it is a relationship, supplies the project J1 with the project with part P2. This is how we are interpreting this type of relationship instance, which is the supply ternary relationships. I will say supplier S2, just look at the pickup any line, R5 supplies the project J3 with the part P3. It supplies that project with P3. Okay, that means here we do have three entities that are involved in my relationship supply. Okay, we call this type of relationship, or the degree of this relationship, by a ternary degree. As I mentioned for the ER, how we are going to represent relationship, it is displayed as diamond-shaped boxes, which are connected by straight line to the rectangle boxes that will represent the entity types. Works for, this is a diamond shape. Managers, this is a diamond shape. This is a relationship. And they are really linked to, we're going to see later what is meant by two lines and one line. But the main thing is to understand within your diagram which one is the relationship or represent a relationship inside your ER diagram. You look just for those diamond shape and means this manages, it is a relationship. Works for, it is a relationship. Dependent of, it is a relationship. Supervision, it is a relationship. Controls is a relationship. And it is relating, linking some entities together. Clear, Shabab? Any question for this one?
Clear, Doctor.
Good. Let's move on next to the other concept. Okay. We looked at the relationship, the degree, and the role names and the recursive relationship. When you talk about the role names, you are specifying the role that participating entity plays in each relationship instance. When we said, for instance, I do have employee. Employee, what does it mean? Employee, it plays the role of an employee in the department. When we say worker, when we say department entity has a department entity has a role of a department to play within our database. When I say a student entity, that means that student has a role to be played within the student database and so on. This is what is meant by a role. For each entity has some significance. Okay, the name of the entity will dictate, will show you, will give you an idea about the role of those elements that are contained within that entity type. I do have for the relationship, we do have special relationship, which is the recursive relationship. Let's have a look at our diagram ER with this relationship. What can you say about what is now between this relationship and, for instance, works for, works on, controls? What can you say?
It's Doctor, it's go from employee to employee.
Barakallahu fik. It goes from an employee to the employee entity. It goes from employee and it returns to the same employee entity. For works for, we go from employee to department, two different entities. Works on, two different entities. Controls, department entity, project. There are different entities. But in this example, we do have a relationship that involves the same employee entity. We said it is a recursive. Why? Because it is based on the type of relationship. Relationship, it is supervision. معناها مسؤول. مثلا رئيس قسم ولا مدير. That guy, مدير, director ولا رئيس قسم, is in reality, he is an employee. Okay, Shabab? That's why it goes from the employee to the employee. I will say Muhammad is the head department of Ali, where Ali works on that department. That means both Muhammad and Ali are within the same entity. One is a supervisor and the other one is the supervisee. Okay, Shabab? This is known as recursive. That means it goes, it is relating to the same entity. Okay, guys?
Okay.
Inshallah, we stop here.